Hello, this is Lee Junhyuk from New World. In this session, I will introduce the ESP-8266 Wi-Fi module, ESP-01, which is available at a very affordable price. Let me explain it to you while looking at the product right away. This here is the ESP-8266 Wi-Fi module, ESP-01. You can purchase it from DeviceMart through the link shown below, and it costs only around 2,000 won. To use this ESP-01, you connect it to a board like an Arduino and connect to Wi-Fi using UART communication. For reference, the default baud rate of the ESP-01 is 11-15-200 bps. Typically, when connecting an Arduino to other UART devices, you use a feature called software serial, which utilizes GPIO pins. However, the maximum baud rate that software serial can achieve is only 38,400 bps. Therefore, it is not possible to directly connect the ESP-01 to an Arduino Uno due to the speed mismatch. In this session, we will set the baud rate of the ESP-01 to 9600. To set it to 9600, we will use the TTL to USB converter that I introduced earlier. We will connect the ESP-01 to the converter, then connect the converter to a PC to change the baud rate of the ESP-01. The connection should be made as shown on the screen. First, if you look at the pin map of the ESP-01, this is the top view of the ESP-01. Starting from the top left, if we number them 1, 2, 3, 4, 5, 6, 7, 8. Pin 1 is ground. Pin 2 is GPIO2. Pin 3 is GPIO3. Pin 4 is RxD. Pin 5 is TXD. Pin 6 is the enable pin. Pin 7 is the reset pin. And pin 8 is the VCC pin. Connect pin 6 and pin 8 of the ESP-01 to 3.3V on the TTL to USB converter we saw earlier. The ESP-01 is a Wi-Fi module that allows microcontrollers to connect to a Wi-Fi network and make simple TCP/IP connections using Haze-style commands. It is widely used in IoT projects due to its low cost and ease of use. Then, connect the RxD pin of the ESP-01 to TXD and the TXD pin of the ESP-01 to RxD. The RxD and TXD pins are used for serial communication, where RxD stands for receive data and TXD stands for transmit data. Okay? Serial communication is a method of transferring data one bit at a time, sequentially, over a communication channel or computer bus. Next, connect the ground pin to the ground on the converter as well. Grounding is essential for completing the circuit and ensuring that all components share a common reference voltage. You might understand why pin 8 is connected to 3.3V, but the reason for connecting pin 6 to 3.3V is that pin 6 is the chip enable pin. The ESP-01 operates when this enable pin is high, so we connect both pin 6 and pin 8 to 3.3V on the converter. As shown here, connect the ESP-01 to the TTL to USB converter. Once you have connected the ESP-01 to the TTL to USB converter, connect the converter to the PC and then run Arduino. The Arduino IDE is an open source platform used for building electronics projects. It provides an easy-to-use interface for writing code and uploading it to your Arduino board. After running Arduino, you can select any board from the Tools menu and choose the port connected to the converter. I have already selected it. In this state, click the icon to open the serial monitor. The serial monitor is a feature in the Arduino IDE that allows you to send and receive serial data to and from your Arduino board. It is useful for debugging and monitoring the communication between your Arduino and other devices. When the serial monitor opens, you will see options at the bottom. Select both NL and CR from the options and set the baud rate to 11-15-200. The baud rate is the speed at which data is transmitted over a serial connection. It is measured in bits per second, BPS. Then type AT in uppercase and press enter. If OK appears, it means the ESP-01 is communicating properly. The AT command is used to change settings of the ESP-8266, and it is also used to control other sensors and communication chips. Besides AT, you can also type AT-PAGMR to display firmware-related information of the ESP-01. Firmware is the software programmed into the read-only memory of a hardware device. It provides the necessary instructions for how the device communicates with other computer hardware. To set the baud rate, type 8 Psuart def 600 8.1 eon 0, as I mentioned earlier. This command sets the baud rate to 9600 bps, with 8 data bits, 1 stop bit, no parity, and no flow control. Press enter, and if OK appears, the baud rate is set to 9600. In this session, we have set the baud rate of the ESP-01. In the next session, we will connect the ESP-01 to the Arduino Uno for internet communication. Note that the Arduino Uno operates at 5V, while the ESP-01 operates at 3V. As mentioned in another video, due to the different operating voltages, they cannot be directly connected for UART communication. In the next session, we will use an ESP-01 converter, which adjusts the communication voltage between the ESP-01 and the Arduino Uno to connect them. This converter contains the logic level converter we explained earlier. Logic level converters are used to safely step down or step up the voltage levels between different components. They are essential for ensuring that devices with different voltage requirements can communicate with each other without damage. See you next time.